This is the Second Studio, hosted by the Architecture and Design Office fame. My name is David Lee, and with me is Marina Borderonnet. The two of us are partners at the office and, of course, hosts of the show. And our guest today is Ted Hall.
Ted is the founding partner of Spearhead, a digital fabrication company based in British Columbia, and they are specialized in timber and steel.
Yes, and most of their work, or a lot of their work, focuses on the single-family residential space, but they also do commercial work. They call it their free-form type of projects, which are much more complicated. And Spearhead's been around for about 35 years, I think. And with Ted, we talk about how he started his company and everything there is to know about his company and fabrications and the complexity of fabrications, teamwork, interfacing with architects and engineers and contractors, how they do things, fabricating things and components off-site at their facility, and then them being shipped onto the project site and installing it. Everything. We cover it all.
Yeah, and if you're not familiar with the type of fabrication that they do, you should look them up. They've done probably some of the most complex pieces on very iconic pieces of architecture. So you should definitely look that up. Yeah,
and as you'll hear, he's worked with actually a bunch of the people that we've interviewed on the show. Olsen Kundig, Dow Built, Blake Flato, and a bunch of others he listed, I can't recall. But it was a great conversation. I think you guys are going to enjoy it. Sponsors.
If you're starting to laser scan your renovation projects for accurate as-builts, a client at some point has probably handed you some wonky CAD drawings from 17 years ago. Enter Integrated Projects, or IPX for short. IPX is a scan-to-BIM platform that converts your 3D point cloud file from any major LiDAR camera into standardized BIM and CAD files. The best part is that their website lays out the price and turnaround time instantly. Start that interior renovation project on the 50-yard line with accurate drawings in 3D and 2D. Click the IPX link in our show notes to get your first instant quote.
Managing design projects and specifications can be a headache, but Programma makes it easy. Trusted by top firms in 75 countries, it's the world's most beautiful software for interior designers. Its suite of powerful tools offers simpler client interactions with less back and forth, saving you hours of manual work and making your job more enjoyable. Stop struggling and start thriving with the seriously powerful Programma. Click the link in our show notes and get 25% off an annual subscription with the code Second Studio at checkout. Trust us, you'll wonder how you ever worked without it. The Second Studio podcast is made possible by support from Autodesk.
Autodesk has been part of the design conversation since 1982, providing the tools that help architects around the globe imagine and create beautifully designed, memorable buildings that people love and admire. Autodesk supports the work of the Second Studio, bringing the architecture community together, sparking curiosity, and leading vibrant interviews with the industry's visionaries and thought leaders.
The Second Studio works hard to carry the architecture conversation forward, and Autodesk is proud to contribute to this podcast. Learn more about Autodesk by clicking their link in our show notes. This is the Second Studio with myself, Marina, and our guest, Ted Hall. Here we go.
Actually, I'm American. I was born in New York, raised in Canada.
Oh.
My whole extended family is from Ivy League, USA,
Really?
as my folks put it. They moved as far away from that as they could and remain on the same continent. But
Wow.
I grew up in a very artistic family. My dad was a hobby photographer, but really accomplished at it. Had a darkroom in our house as a kid. My mother, a potter, and very passionate about that. We had a pottery studio in our house as a kid.
Wow.
They had all sorts of artist friends and architect friends and that kind of thing. And looking back, that's definitely an influence in my interest in design in general. My first love in design was photography, for sure.
Oh.
And I actually really got into ceramics as well. I taught the wheelwork in grade 11 and 12 in my high school class.
Okay. What kind of photography?
Mostly landscape photography and that kind of thing. And then I actually went to school studied English literature, thinking I would go into photojournalism. And
Wow.
Okay.
I did pursue that for a little while, but I had kids at a young age and realized that wasn't, my heart was never really in it. It was mostly about photography.
Gotcha.
Yeah.
Gotcha.
Mm-hmm.
So you did go to school, you studied these things, you practiced for a bit in that kind of field, and then you pivoted. the fabrication space the next step for you, or did you have other things that took place before then?
I actually, when I got into carpentry at a very young age, and that was influenced from my folks. I mentioned grew up in this sort of artistic environment. They had a good friend, an architect, who designed a really amazing house in Vancouver. We were fortunate to live in one of the nicer parts of Vancouver, in my view. Basically, had the ocean in the front yard and the back, and the mountains in the backyard. And yeah, when I was a teenager, my folks had this house built that our whole family participated in the process of that.
Really?
The general contractor behind it, and it was really a fantastic Canadian architect. And the general contractor behind it was a bunch of Danish guys, 4 Danes that had apprenticed together. I think 2 of them were furniture makers and 2 of them were master carpenters.
Oh.
And that was an early exposure to sort of a deeper sense of craft that I think is recognizable today still in Western Europe, the strength of sort of the guild system and how in Western Europe to call yourself a carpenter, that's an educated person, right? That's not someone who ends up doing carpentry, which, I mean, there's certainly a lot of skilled people and exceptional work, of course, going on in North America, but I do have tremendous respect for just the importance of craft that you see in Western Europe, and was fortunate to get exposed to that at a really young age through the building of this house. And it was kind of through that I supported myself through university in carpentry and doing renovations and that kind of thing in Vancouver. And through a family connection, ended up building a classic timber frame barn, all with like mortise and tin and the real McCoy wood joinery that was designed by a German master carpenter who was working for family friends that owned a large ranch property. And I think I was 20 years old when we built that barn. And it just struck a nerve with me. And that was right around the time that a fellow by the name of Ted Benson and a group of others in the eastern U.S., in New Hampshire specifically, I think they were just publishing their second book around then. And there was this kind of revolution taking place of, that was the birth of timber framing in the U.S., or the rebirth, you might even say, because there is some history there, again, which is, really came from Western Europe. They never stopped timber framing in specifically in Germany, Switzerland, Austria, France. And this group of folks in the eastern U.S. Traveled to Europe, saw what was going on there, got inspired by it. And after building this barn, I went and took a course with them, and I was just fired right up. That was never looked back. So fast forward, I ended up moving to Nelson, British Columbia, which is where we live now. Lived here for 30 years. And the started Spearhead about 35 years ago. When we moved to Nelson, I had a couple employees move here with me, and we've just been through a long and steady growth. And it's proved to be an excellent place to live and to operate what's turned into quite a unique business.
Yeah. Except when there's fires, unfortunately.
Yeah. Yeah.
But
the whole place is burning up right now.
Yeah, we're used to those in California for sure. I was curious, what was that house like? That architect's house, the one that it sounded like your family got together and friends and built the thing?
Yeah. Yeah, it was funny. It was kind of a a fusion of my folks' past, growing up in New England, with West Coast modernism, um, and it ended up getting published in a couple of design mags, and it was uh, it was a great family home. It was definitely built with wood. The Danish guys that built the house, they did their own concrete and framing, and when they got the place dried in, they moved a full like commercial mill workshop into the
Wow.
house. They built
Wow.
the windows and doors and cabinets at
Really?
an incredibly high standard. Yeah, these guys are
Wow.
absolute master craftsmen. And my brother and I worked for them as unpaid slaves.
Yeah,
Um,
yeah.
but
Apprentices.
exactly,
Yeah.
but we weren't learned through osmosis and maintained a connection with them for years after that. And yeah, it was a privilege to be exposed to that, I think, at a young age.
Yeah, that's really cool. Oh, I might have to get the name of the house. I wonder if we can find it online. I don't know. It's probably out there somewhere.
Yeah, it was published in Western Living magazine many
Western
years
Living.
ago. I could actually dig up the article, I bet, and send it to you.
Yeah, we
That
should
would
do
be
that.
cool.
I'd be
Yeah.
very curious to see it,
Hmm.
and maybe we can stick it in the video or something. Um,
Hmm.
you had mentioned that there was a very strong sense of craftsmanship and woodworking that came from Western Europe and a few of the countries. And
Hmm.
it made me think of a general question, which is, do you think that craftsmanship and valuing it is slowly dying off? Because sometimes I get that impression with, I don't know, things in general, or maybe even oftentimes in architecture and construction. The speed, like everyone
Guys,
wants to do things faster and faster.
especially in the US, I would
Especially,
say. I feel like Europe has an appreciation for this thing still.
probably
But
more so in the United States. I don't know.
Yeah. Well, of course, it's difficult to generalize, but I, I, I think to a large extent, yes. And I think almost technology, in a sense, is displacing craft.
mm,
And it's actually something that we talk about a lot here at Spearhead is how can we approach technology with a sense of craft, use technology um, to serve like the big idea behind what we're trying to do, to understand materials and process, um, but use technology at the same time in a way to really not just make design more efficient, but try to look at some of these, everything we do, we model in 3D, we're using CNC machines to cut parts, and it's an amazing process, but garbage in, garbage out in a sense, right? These machines
Gigo.
will do, yeah, they'll do whatever you tell them to
Yeah.
do. And uh, if you don't have a good understanding of the intent behind a design and try to use that technology to serve that intent, um, I, I think there's something inherently missing, right? So approaching the technology with a sense of craft and um, trying to bring more integrity to the work through that.
Hmm.
I think that's what gets us up in the morning.
Yeah, yeah. And I'm
Hmm.
actually thinking of parallels to our own professions or our profession of architecture. And
Hmm.
it's a funny thing, on our side, because architects don't actually make anything. We design and make drawings. That's what we make for the most part. But a lot of the technology we have is more like software technology. And oftentimes I see in particular with maybe the younger generation, the first or maybe even the general public, the first instinct or first thought about the tech is more as a way to just expedite and kind of take shortcuts. Like, why go
Hmm.
through these steps to do this thing, this drawing, let's say, when I can just click twice and then the computer will spit out kind of a solution for me and whatnot. And I know there's a lot of architecture have hesitations about that. Mostly that kind of philosophy, that kind of that approach to whatever it is you're doing, right?
Hmm. Hmm.
Versus what you're describing, which is leveraging technology, yes, to be more efficient in certain processes, but also to look at quality to see if we can do things different and better. It's an interesting blend of those two sides that you guys are doing extremely well, I think.
Yeah, and I think something that um, we try to practice in our work is to think about deliberately establishing a link between like a design process and the actual physical parts. And that's the interesting thing about a digital design process that uses CNC machines downstream, right? That is a digital fabrication process. Can we actually establish a workflow that you could trace the development of a design into a three-dimensional shop drawing, into the programming of machines to cut parts, and create this sort of tangible connection? And then all of a sudden, I think it makes this idea of trying to optimize the technology to serve the design. It's a more attainable thing, and I think this idea of approaching that with the sense of craft becomes much more tangible, right? It just becomes much more real. The more sort of complex the components be, the more important it is to establish that link. And it's interesting. It's a lot of our more, like we really are engaged in two different types of work. There's this, what we call our core work, which is not necessarily complex form and whatnot. It's a lot of our residential work we refer to as core work. But then there's another stream to our work which we refer to as freeform, where we're looking at complex geometry and whatnot. And those unconventional projects require a bit of an unconventional process to pull them off. What we're always trying to do is establish, a workflow and a best practice that is not just the most efficient, but the most sort of authentic way of fusing the architecture, the engineering, and the manufacturing methodology into one cohesive effort. We're trying to deliberately apply those lessons learned back into our core work, where it's perhaps less obvious that you might consider that approach because the complexity of form isn't there.
Right.
But we definitely see the same results when we're able to rally a group around that approach.
So a couple questions. The more, how do you describe the formless projects? The ones that are
freeform. Just referring to more complex geometry, really.
Gotcha. And those projects are typically like pavilions and things instead of houses. Like what are those for?
Yeah, they're often commercial projects, pavilions. Okay. We've been doing some large scale public art projects, and we're getting into larger. We've done some work with Shigeru Ban. The Aspen Art Museum was a bit of a pivotal project for us. Some more, public type projects on the boards right now as well.
Gotcha.
And you mentioned...
We had, I was just going to say, on Shigeru Ban, we were actually in Switzerland not too long ago, depending on when this recording comes out. It might have been a few months. But we saw his, I don't even know the name of the building. I think it's an office building in Zurich.
Yeah.
And it features mass timber framing. You probably...
Media?
Yeah,
I think so. Yeah, it has the kind of oval ellipse kind of profiles. It was pretty. It was pretty cool.
Yeah, it was pretty cool.
Yeah, the software that was used to produce the shop drawings and the manufacturing equipment, the CNC machines used to cut. To fabricate the timber on that same software and same machinery that we have.
Gotcha.
So I was wondering for those more like freeform projects, because the fabrication and the design parts seem to really work together throughout. Like at what phase does the project need to get to you before, fabrication can even start? Like do you need to get to CD drawings from the architects in order to take on the project, or can you get on it like as soon as, I don't know, schematic or design development and, bring your insights and your knowledge from the fabrication part into those phases?
That's a great question. What 100% of the work that we do are engaged in two capacities. Initially engaged in what we refer to as design assist, which is essentially a consulting role, which would lead to the definition of a scope of work, the definition of a strategy for a build, and lead into a supply contract associated with that. But design assist, it's a term that's kind of widely used in the mass chamber industry now, and I think it's being diluted a little bit in our view of what design assist really means. To us, it's about integration, and it's about optimization, right? And optimization specifically of available technology in our case, right? Like we have very deep resources and extensive experience in approaching these complex projects. And of course, if we're able to engage at a schematic level of design, we can make good decisions early about the scope of work that you might fabricate offsite versus what you would do on site, and how to make sure that those elements can run concurrently and really benefit from the technology behind the fabrication side.
Yeah.
So we don't really bid on anything, and I think that's why on the commercial side, the work that we tend to get involved in is the work that is of such complexity that it warrants the engagement of a specialty fabricator early on in order to de-risk the project and pull it off, quite frankly. Yeah. So the design bid build model is something that we don't really engage in, right? We just don't see any efficiency in that. There's no way that our capabilities and the resources that we have access to are going to be optimized through that. So there's we refer to DFMA, Design for Manufacturing and Assembly, which is an acronym kind of borrowed from product design that you're seeing more and more in the development of architecture. And I think it just makes a heck of a lot of sense. I think we've proven to ourselves and the project partners that we've worked with that there are a whole bunch of efficiencies that come through engaging in that collaborative process. And I think there's a direct correlation between, like, there's the potential to offset a lot of the redundancy in the design process, right? A lot of the duplication of work when you got an architect, an engineer, and a fabricator all working in 3D, but all working really kind of independently in somewhat disconnected models. And it's really only as you get into construction documentation that resolution really gets figured out. Some of the, I think what we see is, on a positive note, when we're able to engage in that design assist role and we're able to sort of co-develop the solution of a project and contribute to the resolution of the design digitally, we end up with fewer parts, more optimization of materials, of machine process, and ultimately cost and schedule control in a project I think would be difficult to achieve otherwise.
Yeah, I agree. It's the design bid build approach in the more general sense of architects and contractors and how they work together is something that we're pretty strongly against. It just doesn't. And actually, your reference to the DFN, the design
DFMA.
DFMA. You can tell my short-term memory is not very great. In product markets is an interesting one because we like to work, let's say, with contractors by onboarding them basically like really, really early. So they're doing pre-construction with us, and we don't avoid the bidding situation because it never works, as we all know. The bids are always too high or too low, and no one's reading the drawings and all this kind of stuff. But the way that I sometimes explain the benefits of having the team earlier, including the engineer and even fabricators like yourself, is that, well, if imagine you're going to create, I don't know, the iPhone or any product, it would make no sense for your design team to work in silo for 6, 8, 12 months, and then only after that point talk to the people who are actually going to fabricate it. Like, that would be ridiculous. You'd never do that. And yet, that's basically the design, bid, build model is kind of that, right? And so anyway, I agree that it's kind of antiquated, and I feel like more and more generally the industries are moving away from that. And we have to, especially absolutely. For stuff like with what you do, the complexity of it.
Yeah. I think, it's possible to have kind of a proof of concept concurrent with design development, where as a specialty fabricator, we're not just waiting for the architect and the engineer to develop the design so that we can price it. We're trying to contribute digitally to the resolution of the design and prove out literally the runtime on machines to cut parts, with one approach versus another approach. And essentially, that's the thing. Once you get to a point that you program a CNC to cut any given part, the runtime to produce it. And that amounts to data. That data-driven approach can be embraced very early in an architectural design process. And if you apply that effort to the elements that are maybe the big move architecturally, or represent the area of greatest complexity and therefore risk in a project, like there's a correlation to cost certainty and schedule certainty and design integrity that comes through that process that can be of direct value.
Yeah, super well said. Yeah. I just want to ask a couple of basic questions about what you guys do in your services, because people might be listening wondering a bit more about that. So just, I don't know, maybe give us a brief overview of what are the things that you guys do, and if there's anything that you don't do or anything that you specialize in.
What you mean? What do we actually supply at the end of the day?
Supply, yeah. I mean, do you work with timber and metal? Are there certain metals you work with, don't work with? Just kind of like the basics, so people have an understanding of reference.
Yeah, well, I mean, we started as a timber frame company, and we also developed a mill workshop very early on. So that's kind of interesting, because the balance of skills, of people with carpentry backgrounds and fine woodworking backgrounds, but balanced with on the digital planning side. We use that terminology instead of the design side, so it's not to confuse our role in the front end. But in-house, we've got people with backgrounds in architecture and engineering and in construction. But as I said, we started out in timber framing. We are timber fabricators at heart. And the bulk of our work, the bulk of our work's in the U.S., has been for 30 years, probably 75, 80% of our work. And that the bulk of that is custom residential work, and much of which is repeat work with really exceptional architectural firms we've worked with for years. I think we've done 65 projects with Olson Kundig now, multiple projects with Walker Warner, Lake Flato, Bullen Swinsky Jackson. There's a whole number of really fantastic firms.
You listed all the heavy hitters.
Yeah. And early on, the focus on the work we were doing with them was definitely wood forward. And over time, just as their designs have evolved and just the evolution of their work, we've applied those lessons learned in exposed structure and working with heavy timber to a much broader scope of work. So now about half the revenue of Spearhead is actually structural steel and architectural steel. We apply the same methodologies, the same process to the fabrication of wood and steel. It's a digital process. And I think that's something unique about the way we approach our work. There are many mass timber companies out there, talking on the fabrication side, and timber frame companies and steel fabricators and structural steel and architectural steel and so on and so forth. Our focus is really on integration. So when we get in these custom residential jobs, the complexity often resides in the interface between traditionally isolated scopes of work, between the wood and the steel components, be them exposed or concealed, and then between other elements of the project like mechanical, electrical, and envelope and glazing, and the interface with concrete, all those different scopes of work. So really, if we look at the distribution of effort in our shop drawing process, there's obviously the shop drawings required to guide the manufacturing of the scope of work that we supply. But in association with that, the interface coordination of a whole spectrum of work, I think, is a big differentiator for us. So as far as the residential work goes, I think the focus is really on that integration and on kind of comprehensive fabrication, looking at a structural system as a complete scope of work, regardless of the materiality, regardless of whether it's exposed or concealed. And then on the freeform side, on what tends to be commercial work, the focus is often a little bit more specific to the fabrication of timber and addressing more complex projects where we're able to engage in this design assist role early on. And I think a lot of our flagship projects have been on that commercial side, more aspirational timber structures.
So I'm a little bit curious, how did technology came into the mix? Because you really started again
30 years ago?
35 years ago. So that was like in the 80s.
Well, actually, we're 2020, so that might be early 90s, which is kind of
or 90s.
Yeah.
But you started, making things with your hand, being very much in direct relationship with the materials and all of that. So how did technology, computer, software, and all of this aspect really became an interest of yours, or something that was interesting for Spearhead to explore?
Well, probably goes right back to being exposed to some highly skilled Danish carpenters at a young age, and then just through family being knowing a bunch of European folks, and traveling to Europe, to Germany specifically, when I first really got fired up about timber framing. We became the first company in North America to use CADwork software, which is the design software that we use to guide our manufacturing process.
CADwork is the name of the software.
CADwork, yeah. Okay. It's got around 80% market share in the mass timber world. And it's work that was born from the fabrication side, not the architectural side, right? So we started using CADwork, which is really designed to interface with CNC machinery. Started using it long before we owned our first CNC machine. And then about 28 years ago, we bought a Hundigger machine, which was, I believe it was the first Hundigger in North America. Well, I know it was. We were the second owner of the machine. So that it's a German designed machine to cut heavy timber, that kind of revolutionized the industry. And that was our first real foray into the using technology.
You're like, wow, this is amazing.
Wait, is it a CNC or is it a mill, or what kind of?
Yeah, it's a large format CNC machine designed to cut heavy timber. Um,
Okay.
and yeah, we would use it originally when we first started using it. We were using it to cut mortise and tenon joinery to essentially do traditional joinery, but using CNC machinery.
Oh,
Hmm.
cool.
And over time have evolved to use that. We're now on our second and just in the process of ordering the third generation of that same machine. Um, and now we use it in really quite dynamic ways in all with wood, but using engineered wood, solid timber, and conventional framing products as well.
I bet that's an expensive piece of equipment.
Yeah, it's a significant investment, and it's not just the cost of the machine; it's the cost of the building and all the supporting infrastructure associated.
Hmm.
Yeah.
I was wondering, with the digitization of the process that kind of happened over time and has evolved, obviously, over the past 35 years, was there ever a concern or is it an issue with the woodworkers becoming disconnected from the woodworking? Because, using a chisel to make a mortise and tenon, it does obviously require master skill level, and it's a very immediate, as you were saying, we're in a very immediate like response to material. You're very personal with it versus the CNC process. Is that, I don't know, does that come up, or does that come up with maybe with like the younger staff, them not understanding the sensibilities of things?
Early days, we anticipated that may be the case, but it really wasn't. What we found is we were able to, the people that had that background in the craft, that had that skill to actually do that work, were excellent candidates to learn to use the software, to use the machine to do the work instead of doing it by hand. And then to push the engineering and to push the use of materials in different ways because of their experience on the craft side. And I think what it's done is it's enabled us to take on more complex and more interesting and more kind of rewarding work on the fabrication side as well. So the skills definitely required. I think they're arguably able to apply their skill to more results and more courageous projects, really.
Yeah, cool. That's great. And now let's give a shout out to our sponsors who support our show.
In our office, we do a lot of remodel projects, and getting accurate as-built of homes was always a challenge. As you can imagine, manually surveying a home is tedious and time-consuming. Fortunately, we discovered Canvas, an app that allows us to use our iPad or iPhone to scan entire homes quickly using LiDAR technology. Canvas processes the scan and produces 2D drawings or 3D computer models of the home. The file format are SketchUp, ArchiCAD, Vectorworks, Revit, and others. So click the link in our show notes or visit canvas.io/SSP to get your first as-built free. We are supported by Enscape, which is a fast and easy to use real-time visualization and VR tool for the AEC industry. Enscape is not a standalone application. Instead, it's a plugin which makes things much easier. It plugs into Revit, SketchUp, Rhino, ArchiCAD, and Vectorworks. And with Enscape, you can create realistic renderings, 360-degree panoramas, and videos. You can also immerse clients into VR to give them a deeper understanding of their building. Enscape is used by more than 500,000 monthly users worldwide from over 150 countries. So if you want a fast and user-friendly real-time visualization experience, click on the Enscape 3D link in our show notes.
If you're still using separate 2D and 3D computer programs in your office, then stop that. Get with the times and advance to a BIM computer program, and we recommend ArchiCAD. ArchiCAD leads the industry by enabling architectural and interior design firms around the world to freely design, supported by innovative technology that expands as far as the imagination can stretch. ArchiCAD continually evolves with technological advances, allowing architects to push that technology to their advantage while working in an accurate model. Start your free, fully functioning trial today by clicking on the ArchiCAD link in our show notes.
How often do you have to, let's say, invent or tweak a machine to make it do what you need the fabrication process to do in order to get the final product. Like
machine or process in general too.
Yeah.
It's funny that you say that. When we bought our second Hundigger machine, we installed it just in time for to start the fabrication process of what was arguably our most complex project to date, which was there's an architect in Vancouver, Brian Hemingway, who was, a celebrated West Coast architect that was just doing some totally inspired work. And this was an exposed timber structure that was using these incredibly precious materials. We'd salvaged a bunch of old growth timber that had been laying on the ground for 80 years, I think, like massive Douglas fir trees that we ended up creating. We used it as veneer on these large format engineered beams, and we were doing furniture quality timber work on a very large scale.
Wow.
And we had some technical problems with the machine, and ended up bringing a technician from Germany to help us with it, to troubleshoot some of the issues that we had. And he saw that the precision that we were trying to achieve, and he looked at us and he said, "You can't do this on this machine." And we said, "Well, actually you can." We ended up building these jigs that were used to hold the workpiece in very precise orientation in order to do this really complex joinery. And we definitely over time we've used these machines in conventional ways, right?
Yeah.
And have invented systems, and that's where I think the craft really comes in, right?
Yeah.
And looking at the technology maybe a little bit more objectively, and how we might achieve just use it in creative ways to do things that at first glance you wouldn't think you could do using the machinery.
Do you remember the tolerances on that project?
Well, we referred to it as zero tolerance, but literally like 64th of an inch, like perfect.
Wow.
Yeah.
Yeah, that is furniture. Shavings.
So is there anything that you cannot make?
Well, of course, yes. But we joke sometimes that we're enablers of irresponsible behavior by architects.
Yeah, I was going to say.
Yeah, I think just back to that sort of that idea of design assist, and as you mentioned, like the downfalls of the design bid build system. Design assist is something you could associate with pre-construction, right? It's fairly commonplace that a general contractor would get involved in pre-construction early in a project. What we see is typically that's a bit of a reactive process instead of a proactive process. Mm-hmm. I think when we talk about design assist, we're actively trying to be strategists when we come into a project, right? And instead of and really explore what it means to work iteratively and collaboratively with architect, engineer, and builder. And what that means for us is we have the opportunity to kind of do a deep dive early on. We're asking to get involved before a design is complete, before it's resolved, right? And instead of waiting for an engineer to like develop all of the connection details and whatnot and us comment on it, we'd like to really engage with them in parallel, so we can offer a little more access to the technology in a sense, right? And make that a design opportunity instead of a design constraint. Mm-hmm. And if we're able to work in parallel in using the development of a 3D model as the basis of communication, it's really interesting how this sort of dialogue develops, right? Not only are we privy to a deeper understanding of the design intent, um, but and therefore, if we're doing our job properly, we're able to make more relevant suggestions back to the design team that I think really bring value to the project and can enhance the design and make better use of materials. But at the same time, I think the architect, the engineer, and the builder have a little bit more insight into the opportunities inherent in that manufacturing process, so that we become a real strategic partner in that sense, right? And we start to work as a satellite office almost to give more access to the technology and the benefits that that can bring.
That's a super good point, and I like that distinction. Excuse me, because the idea of working with all the different project stakeholders earlier is talked about as an idea fairly often. Sometimes it happens, and even more rarely does it happen in the way that you're describing. And I found that, like, for example, let's say we're working with an engineer on a project. I'm not thinking of anyone in specific, but let's say we're working with an engineer on a project and we described to them that we would like to have them be onboarded from day one and that we can work with each other as we go throughout. And sometimes engineers will say, oh, yeah, that sounds good. But they don't really, but because of maybe their way their fee is structured, maybe it's fixed or I don't know, whatever other things, they don't really intend on embracing the process as you've described it. It's still more of a reactive thing. It's more like, yeah, just call me if you have a question. I'm like, but that's not really what I want. And I also, by the way, I want to make sure that you feel comfortable enough so that I can call you almost any time or set up a meeting anytime and run through ideas with you and not have it feel like I'm wasting your time or you don't want to be on this call because you're not being paid to be there or like whatever it is. And there is definitely a distinction to your point of kind of, I guess you'd call it reactive, as you said, or loose collaboration or fake collaboration versus actual collaborative meetings where we are being creative together. And it's a different mental switch that goes off that doesn't always take place.
Yeah. Yeah, that's where I was mentioning before how the freeform work that we do informs what we refer to as our core work. So you could think of like complexity of form and how what we learn on how we pull those jobs off, how we apply that to more, say, conventional builds. On those really complex jobs, what often happens is we're really blurring the lines between particularly the structural drawings and shop drawings. And I think we're seeing more and more integration in our industry through the use of technology, and it seems evident that that will continue. And if you consider what the future might look like, we're firm believers that we're going to see more and more digital integration in a sense, right? Like for us to actually fabricate part, you need, it's a finite process, right? If to fabricate a part on a CNC machine, it's a data-driven process, right? We have to create a finite three-dimensional model of a part in order to program the machine to produce it. What is, and you might ask the question, like, what is the most direct and deliberate link from a design model to the actual physical part through that CNC process, right? And that's what we're interested in exploring. When you get into these more complex projects, start to question, does it make sense for there to be any barrier between particularly the structural design development and the development of a fabrication level shop drawing, right? Could those actually be one and the same, even if they're two different parties contributing to that resolution, to the development of those drawings? That project that we did, the Aspen Art Museum, was a bit precedent setting for us in the sense that at the outset of that project, working with KLNA structural engineers, really great engineering firm out of Colorado, who we had past experience with through multiple projects. So we were able to bring some some of that momentum forward into a extremely complex kind of risk-laden project, and established a workflow early on that had the intention at the outset was that there would be one set of documentation produced between structural and shop drawings that would be the submittal for on the official side of things, right? The legal document that contracts would be based on, but it would be the same data that would be used to program the fabrication process.
Yeah.
For those more complex projects and products, how many like prototypes or mock-ups, like physical prototypes or mock-ups, do you have to produce to get it right? Like, is the computer digitization enough to test and see what's going to work and what's not going to work? Or when do you ultimately have to like actually test it out in the real three-dimensional space?
Yeah.
Mm-hmm. Well, good question. The more complex it is, the more we'll pursue in that regard, like the more physical mock-ups we'll produce. But when we do go about producing a mock-up, we are always thinking of a resolved digital mock-up first, and then the actual physical mock-up is more to test level of finish and some of the nuances of the fabrication process and final results and materials, of course. But that's what's interesting when you get more versed, more familiar with just the whole workflow and the tolerances that we can expect, and the predictability of a digital process. It changes how we think about mock-ups and what we use them for. But the more complex the geometry, typically, the more mock-ups that we will produce and the larger scale mock-up that we will produce.
So I was also wondering about talking through a hypothetical kind of typical project for you. Let's say a residential project, a house. So the architect would contact you, I suppose, as it sounds like as soon as they want, and say, we're going to work together on this thing. And you guys have meetings once every X period of time throughout design to talk ideas, talk about execution, talk about feasibility, et cetera, et cetera. And it sounds like you just work in that capacity through design and then CDs. And aside from these kinds of meetings, what would be, at some point there's drawings and then there's pricing. How does the process work from beginning to end?
Well, ideally, we are called in somewhere between schematic design and design development. The architectural intent's mapped out. Maybe there isn't even an initial structural analysis yet. Like our entry point in a project ideally is in parallel with the engineer, and in parallel with the general contractor getting involved in our pre-construction effort. And we typically engage in a phased way in design assist. The earlier and the more complex the project, the more we're inclined to pursue a phase one design assist that we think of as like an opportunities analysis, right? Where we're just, instead of a general contractor asking us to look at a predetermined scope of work, we like to just look at a job objectively, take whatever we have from the architect. If it's a 3D model, I mean, we would receive a 3D model from an architect, but even if it's early schematic, we might take the initiative to develop a preliminary model just to use that as the basis of dialogue to develop a strategy for a build, make good decisions early about what you might fabricate offsite versus what might you do on-site, which then starts to generate, I think, some valuable dialogue about materials and methods, and and start to influence how you think about assemblies and how you think about connections to be able to essentially break a project down into components, right?
Mm-hmm.
So that we can think about component manufacturing, looking at the big bones first, looking at the primary structure first, then layering on intermediate structure and architectural elements, and recognizing within that where there's a return on investment of doing a deep dive into the interface coordination of, say, a component of the MEP or glazing an envelope or concrete interface, whatever it may be. And kind of through that process, we see opportunities for us to support the GC downstream in project delivery to be sometimes a hub of coordination to enable some of the other suppliers in the job, say it's the glazing manufacturer, to avoid the need to take field measurements downstream because we're bringing some predictability to the structure and can give them those finite measurements, even a really complex form early on, so that we can overlap more activities and make an appreciable difference to schedule on a project.
Yeah. Yeah.
I think I'm answering your question. Am I?
Yeah. You totally are. And you had mentioned you guys coming on board. So that analysis and observation kind of approach, I think that's what you called it. That's usually around the schematic design phase from the architectural side. And then things become more dialed in during DD, obviously. Yeah.
So initially, we're speculating on strategy and defining a scope of work. And ideally what happens is early in design development, there's a scope of work that's that we've established in a model form that we come to consensus with the rest of the team that becomes, that would be pursuing in a supply contract. And that scope of work we think of digitally as a work set that we would then be responsible to contribute back to the architectural model. Again, so we're not duplicating each other's work, but also so we can stick to the plot to make sure that we're optimizing process as we go through that design development and work into construction documents.
Yeah.
And maybe have the opportunity to recognize where some of the interface coordination I talked about is worth investing in, and then start to break away. We often end up in kind of parallel conversations on the build side with the builder, using, again, the model that we're developing as the basis of communication to look at doing like as in parallel with shop drawings, you might be modeling and resolving the interface with MEP so we can cut the penetrations through elements concurrent with the fabrication of structure. And that's actually, I should mention, that's something that we've through some of these long-term relationships that we've developed. There's a couple builders in particular. You're probably familiar with Dowbuilt, for example.
Oh yeah.
Yeah. So an exceptional Seattle-based firm that we have done, I don't know, probably 50 projects with them throughout the U.S. and have multiple projects ongoing now. Over the time we worked together, they developed what they refer to as their digital construction team in-house, where we're able to work in parallel with them to do finite resolution of interface coordination between some of these scopes of work. So Spearhead isn't burdened with doing all of that on every project. That can be one of our biggest constraints, really. Even though we have a big design team, the effort that we put into that front end digital coordination is quite significant.
Yeah.
And when we're able to work with a builder who has those capabilities in-house, not only does it make our work more efficient, but there can be a huge benefit to understanding cost and schedule on these significant builds that can add up to significant value.
Yeah.
So with Dowbuilt in particular, we've got some real momentum in right away when we look at a project when they're in pre-con and we're in design assist. We're being very resourceful, working in parallel, drawing from past experience and trying to bring best practice to how we support the architect and the engineer to really push the resolution of these projects in, I think, really progressive ways.
It's fascinating, and as you're speaking, it emphasizes and reminds me that the coordination effort for these projects is so huge, and it's, I think, one of the things that the average person, let's say the client, doesn't quite grasp how much time and effort it takes to achieve these things. It takes, like as you said, maybe the bottleneck in your case is that part. It's an immense amount of time to have these conversations, workshops, and trying to figure out how these things are going to play out. And despite it taking X amount of more time than not doing it, it does save time in the end, I've found, because if you just kind of say, well, we're going to see if it works out, or I hope that it works out, anyone that's hoping that it's going to work out, it's not a good strategy. But it does take a lot of work and a lot of brain power and commitment.
Oh, it definitely does. And but at the same time, the offsets to schedule and cost can be significant. Yeah. I mean, the general condition costs on these significant projects, it can keep a lot to keep. It can add up to a lot to keep these jobs afloat. If you can cut 4 to 6 months off the duration of a significant build, it adds up to real money.
Yeah, hundreds of thousands of dollars.
Yeah.
So you guys started with timber, and then you moved to add steel to the mix. Is there another material that you think Spearhead could explore next? Because it seems to me that you guys you just really love your craft, you love the process and the figuring out. And I mean, honestly, that could be applied to any materials, right? So is there anything that's next on your list to try and test out?
Well, we have developed a whole host of kind of strategic relationships ourselves with other fabricators and manufacturers that are working in complementary ways, that are able to communicate digitally on the front end and are using a digital fabrication process to produce their work. That includes some glazing companies. We're actually working with, I don't know if you're familiar with the company Icon that's doing 3D printed concrete. We've got some really interesting dialogue with them right now. And steel fabricators working in aluminum, laser fused stainless, and more conventional steel fabricators that were able to communicate with, in I think, really progressive ways. And I do see us continuing that effort to build that host of relationships that we can recognize opportunities, kind of when we get brought into a project, recognize opportunities to bring some of those project partners in and apply some of the momentum from our experience working together to kind of hit the ground running as we embark on new work. The work that we produce internally in-house, we're actually just planning a fairly significant expansion here right now and looking at increasing our capabilities and kind of getting back to our roots, in a sense, of pushing for more wood forward projects, not by any means giving up on the steel fabrication side. On the contrary, more complementing that, but looking at bringing in-house deeper capabilities in timber forward projects that will just open up new opportunities for us.
Are you thinking of mass timber being applied to larger scale projects, buildings? I mean, like multi-story, multifamily, because has been, and hopefully continues to be, more of a, I don't want to use the word trend, but a pattern or thing that's going to happen.
Yeah, I mean that is a rapidly growing industry, and the landscape is changing quickly. There are a number of large scale producers coming online that are focused on real mass timber jobs, right? On large scale projects that are maybe a little bit more about speed and commodity
True.
than they are about capability. So our focus is really squarely on capability and
Okay.
looking at not complexity for the sake of complexity by any means, but
Yeah.
just
Yeah.
often more aspirational architecture where the expertise, the capability, some of the specific um, fabrication equipment to pull that off is what we're focused on.
The other thing that just came to my mind is, you know, more regarding the way of working, the philosophical approach to the process and the teams and the collaborations and all the stuff that you've been talking about. It all makes sense and is great. It's also, let's be real, you guys work on extremely complex, high budget, very, very nice projects. But I think that a lot of what you guys do, like the lessons learned, I guess you could say, could be applied to a bunch of other professions within the AEC industry and other scales and types of projects. In other words, what I'm saying is, like, I don't think you need to be a Lake Flato, Olson Kundig, or even a Spearhead to adopt some of the principles that you're describing. I don't think it works at a certain kind of tier, maybe with where you're at, but it sounds like a lot of the stuff of again, what you've described could be adopted to, let's say, more of the 90% of the structures being built, and 90% of the architecture offices and GCs
That would
and
make a huge
fabricators.
difference, right? I mean,
Oh, absolutely. I mean, just conceptually, the idea of offsite manufacturing is, there's obviously efficiency in that can be applied to a whole range of projects. And we see that internally, like I was mentioning, in these, jobs with complex geometry that require us to develop a workflow and a very intentional process in order to address that complexity. We are focused on trying to apply that same sort of discipline to more conventional, simpler structures. With, I think, it's easy to establish similar efficiency gains through that effort. It's funny, we often get perceived as being expensive because we're asked to do expensive things, but we need to build houses for ourselves too, and um, and yeah, we try to find a balance between what might be sort of this elite sort of work and community-based projects and kind of local projects that have to address a completely different price point, but where offsite component manufacturing can still be a huge benefit and rewarding to pursue.
Do you guys have engineers in house? Because you work so closely with structural that you might think you have a couple in house to help with the interfacing.
Yeah, most of the work that we're doing is with architectural firms who have quite established working relationships with engineers that they've got a long history with, and then we have a long history with a few, well, half a dozen really exceptional structural firms in both Canada and the U.S. And because the bulk of our work's in the U.S., it wouldn't make sense for us to have, an army of engineers licensed in every state. At the same time, having people with engineering backgrounds in house that can bring, we can vet our work through that internal discussion is really important. So we have some European trained timber engineers in-house that are not working as licensed engineers on our project, but are certainly kind of a internal resource and advisors to our key people here.
Mm-hmm. Yeah, it makes a lot of sense. And I assume the
Yeah.
same might apply. Well, actually, so just talking about the team. So how large is the company in terms of how many people? And it sounds like they also have a diverse set of backgrounds. And I'm also wondering I don't know, are there different groups of people, like ones who just focus on the 3D computer models versus those who do the CNC or I don't know. I'm making stuff up.
Yeah.
Whatever
Yeah.
the breakdown is.
Yeah. Well, we're a team of 70. The distribution of folks here is quite unique in our industry, actually. We've got half on the digital planning side, half in the office,
Wow.
half in the shop. And that is an indication of sort of the distribution of work, right? Because it's a digital design and fabrication process. The folks in the office aren't just technicians sitting there, right? It's um, a lot of the folks in the office have a background of both carpentry and as architectural technicians, or an architectural background or an engineering background. So that understanding of both sides of the spectrum is really important to the work that we do.
Yeah, I would have not guessed it would be that it would be 50-50. That's quite telling for sure.
Yeah, I think that most folks say in mass timber companies, the distribution would be entirely different, right? It would probably be
20-80.
Yeah,
10-90.
in that neighborhood, yeah.
Something like that. Yeah.
You mentioned at the beginning of that conversation that the growth of Spearhead was kind of like slow and steady, which means probably like careful decision and like not to grow too quickly, not to expand, not to get sidetracked maybe. I guess my question would be like, why was that important to you? And do you still think that's the case? Or would there be a world where maybe there would be a Spearhead location in Europe, or like, you would actually
Or in
kind
California,
of like,
where taxes are high.
spread around and maybe, I don't know, like expand the knowledge or explore different techniques or, things like that?
Yeah. Well, we should have my two business partners in on this conversation. I'm very fortunate. My two sons are actually my business partners in Spearhead.
Oh, cool.
And Josh has a degree in architecture, master's in architecture, and Ben studied industrial design.
Oh, wow.
And yeah, the second generation is definitely pushing the company in new directions, and they're quite ambitious. We're going through a growth phase right now, looking at a fairly substantial expansion, which is a little more rapid growth than we've seen since the inception of the company. I think that the fact that we live in Nelson, BC, which is we live in the heart of the resource. We live in the forest. And even though it's a small community, it's a perfect place to be based, just because of our access to resources and supporting industry in forestry and wood manufacturing. But along with being in a small community of 10,000 people, there are some constraints to that have been, that I think has helped control our growth. But I think that what you might view as a constraint for us, for Spearhead, has actually been an opportunity over time. I don't think we'd be the same company if we were in a major center. If we were in Vancouver, we likely would have we would have gravitated towards local work that would have walked in the door. I don't think we'd have the retention that we would have as a company. We realized early on that we were not going to we weren't likely to stay busy doing really aspirational, design-driven work within this community. So we had to be resourceful to pursue work outside. And we had to be resourceful to as a fabricator to use technology to offer a solution that was unique, that would justify us, engaging in projects as far away as Florida, New York, Hawaii, all these places where we're working now.
It's really fascinating.
That's very interesting. Yeah.
And so, actually, going back to the process question, so once you guys fabricate the components, they get shipped out to the site. What happens during construction or construction administration? Are you guys visiting the site also for installation and for other things, or how does I'm sure someone's probably thinking, someone who has not worked with you, what happens if a component arrives on site and it's off, or rather maybe what was built on site was off and therefore things don't fit? Like how do things get resolved, especially when you are so remote? That would be like probably the first concern, I guess, that architects and other professionals would have in the back of their minds.
A valid concern. Yeah, when we started, the bulk of the work that we did, we would install it, and now we install very little of the work that we do. At best, we would offer supervision, and I think that that's a testament to the process that we're able to do that consistently and efficiently. And it really comes down to communication, right? And like I said before, using the development of a fabrication level model as the basis of communication is really the name of the game. And it really does require it really does require kind of an early procurement model, right? If we're doing some complex project, like right now we're doing one of the most complex jobs we've ever done in downtown New York City. We're able to shut the street down for 20 minutes with each delivery of materials, and this is a complete three-dimensional freeform roof on the 6th story of a building.
I'm just super curious, where in the city? Where in New York?
In the I can't remember.
Well, if it's anywhere south of Central Park, which I'm sure it is, it's chaos.
I think if I was, I know the street it's on, but if I'm too specific, I would be in breach of NDA.
Okay, fair enough. Yeah. So we live there, so that's why I'm asking. That's the only reason why I'm asking.
Oh yeah. Okay. Well, it's in a very desirable neighborhood. It's incredibly unique project, and I think it's an example of what we refer to as best practice in bringing our capabilities to the table. But the initial conversation on that project was, the general contractor was convinced that we had to be the installer, and we suggested that we could provide that if necessary, but we suggested that we table that conversation until we were further into the resolution of design and then reassess it. So where we're at now is we have established an installation partner. We've rolled them into the dialogue. We've had regular strategic discussions over a long period of time, regular Zoom calls where we've produced a complete installation sequencing document that is utilizing the fabrication model that basically gives the boots on the ground the confidence that that they've bought into the process, that everybody's more intelligent looking at a 3D model, especially if it's believable, right? And in our case, it has to be finite in order to advance to the manufacturing process, right? And I think it's really interesting just that the dialogue that takes place when we're able to support those folks to really engage and contribute to the process, and we're able to support them remotely to do this really complex work. And there is a cost savings in that, right? For us to uh, for us to send people to New York and put them up, and
Yeah.
It's just not cost effective. If we can work with local labor on that, and of course, if we're very disciplined in the pre-planning, so that it is truly an installation process, right? That we're not having to make adjustments in the field because of coordination issues, and that's where this investment, the front end effort, really pays off.
It's super cool. One of the last questions I have, which is, I don't know, just because I'm curious. So, do you guys have to do any work by hand these days? Maybe like staining, but is everything cut and pretty much finished by machines?
Yeah. Well, the better you get at using the technology and using the machines, the more you want to optimize those capabilities. Mm-hmm. So, yes, the bulk of the handwork is the pre-assembly and the final fit and finish of the components that we ship out of here. There is still, like, the craft is essential. That's that's where you really control the tolerance and the quality of the finished product. But there's a balance of effort for sure. We're trying to leverage the technology to do the heavy lifting, to do the bulk of the work, but we're not afraid to combine some handwork and some finer skilled work to balance things out.
Yeah, interesting.
Mm-hmm.
All right, and our last question is, what is your favorite building?
What is my favorite building?
I know, it's an easy one, right?
Yeah. Well, you know what? There's a project that we did years ago that was it's actually built as a memorial to Lawrence Rockefeller in Grand Teton National Park, and that was a job with CLB Architects, Carney Logan Burke Architects. Just because it was a project in the park where impact on site was reducing impact on site was a real principal driver in design. It just it set us up to think about the construction of the building entirely differently. So we ended up engaged in a really broad spectrum of work there, from the structure to the participating in the final design and the production of some of the exhibit pieces, and even the furniture and the millwork for the project. So
wow.
This is going back over 20 years, but that's what comes to mind when you ask what's a favorite project.
I love it. That's great.
Yeah.
Ted, thank you so much for making the time on a Friday morning. This was so much fun, and we look forward to continuing the conversation. Thank you.
Thank you.
Thank you very much.
Thank you, everybody, for listening to this week's episode. If you want to support our show, then please do by leaving us a review in the Apple Podcast app or in Spotify and YouTube, where you can subscribe and like and comment and all that good stuff. Of course, you can share the show with your friends and enemies. That's appreciated as well. You can find us on social media, basically just Instagram, and the handle is Second Studio Pod, and we have 90,000 followers. Not bad. So there's good discussions happening in the comments and things like that. We post clips, work images, announcements, and all other kinds of fun stuff. What else do we have going on?
We have the hotline that you can text or call if you have any topics you want us to talk about, any guests you would like to see on the show.
Yeah, guest suggestions would be great.
Good ones, please. The number is 213-222-6950. We also have the website, secondstudiopod.com, where all of the episodes are on there with some, guest work images, transcript, bios, all kinds of good stuff. And that's it.
Yeah, we appreciate you guys listening. It means a lot to us. More awesome guests to come. Stay tuned and talk soon. Bye.
Bye-bye.